Hello friends, welcome back to our channel. In today's video, we are going to understand the E-Type Thermocouple in complete detail. If you are learning about sensors, instrumentation, or temperature measurement, then this video is for you. By the end, you'll know exactly what the E-Type Thermocouple is, how it works, its features, advantages, and where it is commonly used. First, let's start with the basics. A thermocouple is a temperature sensor made by joining two different metals. The E-type thermocouple is made from chromel, which is an alloy of nickel and chromium as the positive leg, and constantan, which is an alloy of copper and nickel as the negative leg. When the junction of these two metals is heated or cooled, a small voltage is produced. This voltage is directly related to temperature. The special thing about E-type is that it produces a higher voltage per degree compared to other thermocouples. Its sensitivity is about 68 microvolts per degree Celsius, which is the highest among common types. In simple words, even a small change in temperature will create a stronger electrical signal, making it easier to detect and measure. E-type thermocouples work in the range of about 200 degrees C up to 900 degrees Celsius. That means it can measure extremely cold temperatures, like in cryogenic applications, as well as fairly high temperatures used in industries. One big advantage is that the E-type gives very accurate readings at low temperatures. It's also very stable because it doesn't contain iron, so it doesn't rust or get affected by magnetic fields. This makes it more reliable for long-term use, especially in laboratories and cold environments. Key features. Let's make the features easy to remember. High sensitivity. It produces a strong electrical signal, so even small changes in temperature are easily noticed. Wide range. Works from very cold, 200 degrees C to about 900 degrees Celsius. Good for low temperatures. If you need accurate results in freezing or sub-zero conditions, this is one of the best choices. Non-magnetic. Since it doesn't use iron, there's no problem of rusting or magnetic interference. Long life. Because of its stable nature, it gives consistent readings for a long time. Cost-effective. Compared to some other precise sensors, it is cheaper while still being reliable. Applications. Now, where do we actually use E-type thermocouples? Cryogenics, for extremely low temperature measurements in scientific research. Food industry, for cold storage and freezing applications where accurate readings are important. Medical and pharmaceutical industries, for labs, drug storage, and controlled environments. Environmental chambers, where engineers test products under different temperatures. General laboratory use. Because of its accuracy, researchers prefer it. In short, the E-type is chosen wherever sensitivity and accuracy are more important than handling very high temperatures. Comparison with other types. Let's compare it with some other thermocouples. In simple words, compared to a K-type, the E-type is more sensitive and accurate but cannot measure as high temperatures as the K-type can. Compared to a J-type, the E-type lasts longer since it doesn't have iron, which can rust. Compared to a T-type, both are good at low temperatures, but E-type covers a higher temperature range. So, you can think of the E-type as the high-sensitivity specialist of the thermocouple family. Advantages and limitations. Let's quickly note the pros and cons. Advantages. Very sensitive and accurate. Stable over time. Works well in low temperatures. No corrosion due to lack of iron. Warning sign. Limitations. Maximum temperature is limited to 900 degrees Celsius, lower than K-type or N-type, not the best choice for extremely high temperature furnaces or metallurgical processes. Let's see how E-type thermocouple actually looks like in real. These are some images. Thanks for watching today's video. I hope now you have a clear understanding of the E-type thermocouple. If you enjoyed learning, don't forget to like, share, and subscribe to our channel for more such technical explanations in simple words. See you in the next video.